Okay, so Friday we started to explore the fact that, let me just go back here real quick, right? How one dimension, right, is just affected by a factor of k, because you're just literally affecting one dimension by that scale factor to produce the new shape. Then we looked at areas, and if, for instance, we used a scale factor of 2, we realized that something was happening because you're affecting 2 dimensions to get from one to the other, right? And so when those areas are calculated, okay, we realize that the scale, like if we were to divide it, we don't actually get our scale factor, we get the scale factor squared, okay? And with volume, we realized that there was a scale factor cubed because you have affected all 3 dimensions to get that new box in this case, right? And so the scale factor, when you're trying to find the volume, is actually multiplied 3 times, right? Length times width times height. Every single one of these has been affected by k, so when you go, right, and multiply them, it adds up, right? So you get 2 cubed, okay? And so then we had this word problem here, right? So Jasmine's making a kite using a scale diagram. And in this particular case, we're given a scale. No units though, that's great. The fabric on the diagram is 20 centimeters squared. Maybe I should have done this on Friday, but when you see squared units, you know you're in, right? It's areas, it's 2-dimensional. Okay, that should really ring a bell there. It's not just going to be as straightforward as the other ones. So A, calculate the amount of fabric needed to build the actual kite, right? So they want the actual fabric used in this case. So not only will you write down K, because of this, essentially, maybe I'll just in our notes go and make an arrow, right? And because we're talking square units, I know that my scale factor is affected by K squared. And so then it's area of diagram over area of actual. I turn my scale into a fraction. Some of you like to turn that into a decimal right away. You will get the same answer. I like to keep it as a fraction. The square affects both. Cross multiply and divide, and you get this. Okay. Let's continue this question. I will add B to it. If Jasmine made another kite using 500 centimeters squared of fabric, determine the scale factor used. So the area in the diagram, right, is area of the actual, and there's the scale factor. So I want you to think, like, so this is where we kind of are gonna figure out what do we have, but because of this squared centimeter right there, we know that we're gonna have to use this formula right here. K squared is area of diagram over area of actual. Okay, and listen carefully. They have to give you 2 out of the 3 pieces. They have to, right? So they might give you both areas. They might give you the scale factor and one of the areas. You have to figure out the other one. But you need 2 out of the 3 pieces, or else you can't do it, right? So area of the diagram, I know from up there is 20 centimeters squared. So we're still using that same blueprint. Area of the actual kite, right, that has been made is in this case 500 centimeters squared. This is unknown to us. So they're giving you 2 pieces, you need to figure out the third one. So here's where it gets a little interesting. Okay. So you still write down k squared, don't drop it just yet. Diagram is 20 centimeters squared. Actual is 500 centimeters squared. And so the units cancel out just nicely. That's exactly what you want. So how would you find k in this case? K squared, remember Pythagorean theorem, right? A squared, b squared, you need to square root it, right? Exactly. So we're going to make a big square root like this and go 20 over 500. And to be very sure that you're doing this right, you want to make sure that it's right. You first divide this and then take the square root of it. So grab the calculator that I provided you with. That's the one you want to practice with. So because we have brackets, to call square root, you got to press second. As soon as you press second, you should look on your screen. There'll be an arrow pointing up, right? Then you press, in this case, the x squared button. You see a yellow square root above it. You see it? So second that, and on your screen you should see a square root. And it already opens the brackets. And then you just go ahead, in this case, go 20 divided by 500. Close the brackets and hit enter. And you get 0.2. That is your scale factor. You know which would not have been your scale factor? This. A lot of students just go 20 divided by 500. That's what it is, Mr. Dirksen, 0.04. That means you did not take the square root, because if you go ahead and take the square root of that, right, you get 0.2. This is really the scale factor that has been used. And if you want to be, right, if you would like this as a fraction, just go, right, 2 out of 10 or 1 out of 5 and so forth. Let's keep going. Let's do a cube root. 1 second. And again, you're going to hone in on cube, right? Cube, volume, volume. So you're going to be, first of all, you should notice that both of the volumes have been provided. So, right? And you're going to go K cubed, scale factor cubed is volume of, I'm going to use new or an actual in this case. Volume of the new shape, volume original, sorry, new and original. That's what I'm going to use. You've been provided with both of these, okay? So I'm going to go K cubed, don't drop the cube just yet. Okay. The new one is the replica, and it's an enlargement, right? You can tell that that's going to be the case. And so 1475 meters cubed goes in the denominator, and they cancel out just nice, right? That's exactly what you want. I will not throw, most likely not going to throw a different unit at you when it's volumes and surface areas and so forth. So to find K, watch this very carefully. If you're falling asleep, wake up, right? Cube root, because we're trying to get rid of that K to the power of 3, so you have to take the cube root of 988, 134, 77. And you're like, where's the cube root, Mr. Dirksen? Where is it? Yeah, it's kind of annoying with this calculator. I'll show you where it is right now. So you need to go to math, right? So you see that math button at the second alpha math, right? Press math. And if you go down to option 4, you can either press number 4, it'll choose it automatically, or just go arrow down and then hit enter. It takes the cube root that brings it to the main screen. And same thing, you go 988,000, 134.77 divided by 1475. Close your brackets. I know it's weird, it kind of breaks it up. That's okay. And then we hit enter. And there's our scale factor, 8.75 is the scale factor that has been used in this particular scenario. More examples. A cargo container has been built using a blueprint with a scale of 1 to 15. A. If the capacity of the blueprint is 588.25 centimeters cubed. Determine the capacity.
Excuse the interruption, please. We're asking at this time if there is the owner of a maroon Jeep Cherokee, license plate GNZ117, parked on Benthall Street. I believe that's off of Redwood. If that owner of that vehicle is in the building, could you please come to the office for information about your car? Thank you.
Uh-oh. Yeah. There we go. So moving like from now on, you always want to think K is equal to new over original, or K is equal to diagram over actual. And then make sure you know the variations, right? K squared, K cubed, okay? Let's try this one here. I'm going to highlight the cubes. Okay, there's that. And so because of that, right? And just think capacity is just a hollow object has a capacity. Solid, right, would just be volume, but it's the same thing. Okay, so we're going to go K cubed is volume. I'm going to use diagram over volume of actual, because we're talking blueprint. Blueprint to me is a diagram. Okay, so just keep that in mind. And they gave me the scale, which can easily be turned into a scale factor, right? So the 1 over 15, just plug it in like this. Make sure you cube the whole thing. Okay. I know you've dealt with this in IPR, right? You have done that, except for we use a calculator to work with them here, so no big deal. In this case, we're given, you have to be very careful. Where am I going to plug this in? The volume of the diagram is provided, and it's in centimeters cubed. So you just need to figure out the volume of actual. So this will be a cross multiplying divide. There's no square rooting or anything like that because the scale factor is provided. Cube rooting, in this case, it would have been, because it's provided. So just go ahead and cube it. So watch this. You take 15. This is the power button right here. Watch, look in the screen. Under clear, that little hat there is like your power button. So this is what I do. 15 to the power of 3. So 15 hat 3. That's what it gives you. Right? So I know that 1 cube is just 1, but 15 cubed is this. And I will make that x, right? So you cross multiply and divide. In this case, it's almost irrelevant to divide by 1. But let's stick with the steps so we don't forget about it, right? So in this case, it's going to be a big number. 1,985,343.75. So by default, you round everything to 2 decimals unless you think it needs to be whole quantities. And that's my answer. That's the volume of actual container. Did I give you conversion rates from cubic meter to cubic centimeters? I thought I did. Some not, right? But I would probably give you that on those ones I would give you on a test or quiz. uh, knowing that 1 cubic meter, right, has 10,000 cubic centimeters. So if I asked you to convert this to cubic meters, you know how to convert. You just need that rate. I think I did give you that. Okay, let's keep going. Let's do a chart, a table. So if you have a ruler, comes in handy now. I'm going to use the whole paper here. So let's say this is the original. And we're going to have 1, 2, 3, 4. 4 columns. So as wide as my ruler. So that's 1 there. 2. 1, 2, 3. And the fourth one is at the end here. We'll go with radius in feet, scale factor, okay, surface area in square feet, volume in cubic feet. And so the original is going to be at the top. In this case, it's not always at the top, but it's the one that's completely filled in. If you ever get a table, which you're going to get after today, the one that's completely filled in is going to be your original shape. So for the original, I'm just going to check 6 feet. The scale factor, of course, is 1. Surface area is 452.39. And the volume is 904.78. Let's make a copy of it. I'm using more space for the copy, right? So let's say this is copy 1. Let's do new. Sorry about that, because I've been using new a lot. So let's make a new copy of this sphere. Can we just put at the top, these are all spheres, okay? And spheres have a surface area, they have a volume, it's a 3-dimensional shape, and the radius is just 1-dimensional. Okay, so let's say you make a new one, and all I give you is that the new one has a square footage of 254.47. That's all I'm going to give you there. So the original is here. You made a copy of it, and I know that the surface area is this. So something happened to go from here to here. It was a reduction, wasn't it? So before you do anything else, you have to figure out the scale factor. Okay, so that's what we're going to do in here. And because both areas are given, I know that it's k squared. Which one of these two is going to go on top here? What always goes on top? New, right? So I'm going to grab the new shape that I've created. So that's 254.47. And I'm going to put the original underneath it. And so to get k, I need to take the square root of 254.47 over 452.39. So let's go ahead and do that. Second x2, right? 254.47, 452.39. And that's exactly 0.75. Okay, so we know that it has been everything has been reduced by 0.75. Don't pack just yet because I want to fill in this part here. Now that you have this is very important. You can figure out the rest because we want to have the radius of the new shape. So all you do is k is equal to new over original. And I know the scale factor, it never changes. Once you have it, it stays. So I'm going to substitute that in, 0.75. I have the radius of the original, which is 6 feet. And I would like this one here. I would like the new radius of this new shape. So remember, I put the 1 under here, cross multiply and divide. So it's really 6 times 0.75 divided by 1. You don't have to do the divided by 1 if you get it. But and what do we get there? 4.5. And we know it's in feet, so we got it. Okay? So we filled that in. We know this, we know this, we know this. Last one, the volume. I want the volume of this new shape. So this is kind of like everything in one. Okay? So you start like this. Because we're dealing with volumes, k cubed is volume of the new over volume of original. Okay? In this case, I already have the scale factor that got me the new shape. So you got to go like this. 0.75. Yes, you can turn it into 3 out of 4 if you want. The volume of the original is 904.78. This is your unknown. Okay, the volume of the new shape is that the one we want. So watch what I'm going to do here. 0.75 to the power of 3. And I will write down all the decimals. Or at least 4. I told you that, right? At least 4. It's a little bit tight there, so I'm just going to leave it. X over 904.78. You put the 1 underneath, it's multiplying across. So X is equal to 904.78 times 0.42, and that keeps going. Can you look on your screen once? I'm going to go 904.78 times this whole thing. If you press second, look on the screen just real quick. Second, and then this negative down here, you're going to copy the previous answer. So I'm going to go this times answer, which is the previous one, and then hit enter. So it's 381.70 is the new volume. Okay. Okay. Homework. Pages 9 and 10 in the workbook. There's actually quite a few of these charts. Okay, so this table, this kind of thing that I'm just doing here, you can do that there. I'll post the answer key. If you haven't done page 7, you need to go ahead and do page 7, okay? Because we're testing on Wednesday, right?